Section 7.3, volumes by shells. Let's say I gave you this picture. This is the graph of y equals minus x squared plus 4x. And I wanted this region here. So this is 4 comma 0 right there. And I told you I want you to spin that region around the y-axis. Could you do it? Yes. Good answer. How would you do it? What's that?
By shells.
Well, we don't know how to do it by shells.
No,
So
shells is easier.
So let me rephrase my question. Can you find that volume using discs or washers?
Yes.
Yes. Okay. But it's not easy. Because if I'm going to use discs or washers and I'm going to spin around that axis, how do I have to build my little strip? Horizontally. Okay? So when you're using discs and washers, your line of revolution and your little strip are always going to be perpendicular. So I would have to build my little strip this way. And that immediately causes some problems. What are the problems that immediately causes? I have to, when I set up my integral, my volume is going to have to be something dy. Oh, let's sneak my pi in the front there. And why is that a problem?
Because you have x squared and x.
Because I have x squared and x. What I would need to do is I would need to take this equation and somehow get x equals something with just y's in it. Can you do that?
No, but it's
Okay, how would you do it?
Add 4 or subtract 4x and no. Make it square.
What's that? You could do it by completing the square. That would work. You can also use the quadratic formula. This is something that's never taught. It really should be. What I'm going to do is I'm going to rewrite this as x squared minus 4x plus y equals 0. So all I did is I added the x squared and I subtracted the 4x. If I want to get x all by itself on this equation, I can use the quadratic formula. Except, what am I going to use for c? Instead of c being a number, I'm going to use the letter y. So I could write x equals negative b, that's going to be 4, plus and minus the square root of b squared, that's 16, minus 4 times a times c, so that's 4 times 1 times y, all over 2a. And then I could simplify a little bit. That's 4 plus and minus the square root of 16 minus 4y over 2. Looks like crap? I don't like it either. But I'll make it look slightly better. Notice that I can factor a 4 out of 16 minus 4y. And then I can take the square root of 4. What's the square root of 4? 2. So I can write this as 4 plus and minus 2 square root of 4 minus y over 2. And then I can kill a 2 from everything. So this is 2 plus and minus square root of 4 minus y. So I can actually get x all by itself. But it was not easy, was it? Even worse, yesterday, instead of having a hump that looked like this, that was minus x squared plus 4y, remember we had that problem with sine x? Can't see. Remember we had sine x and we saw we'd have to use sine inverse, and we said we really can't do that. Would have been a big problem. All right, so can we answer this question? Yes. Okay, so when I take my little strip here and I spin it around the axis, am I going to get a solid cylinder or am I going to get a washer? I'm going to get a washer because I got a gap there. All right, so my answer would be volume is pi times the integral. The long strip would go from here all the way to the axis. So how long is that? Well, it's not always.
X squared plus 4x
It would be, except
With y.
everything's got to be with y's. So it's the further one away. So that must be the 2 plus.
Plus or minus.
It's got to be just the plus one. It can't be plus or minus. It's got to be one or the other.
Oh, yeah.
It's the one further away, so it's got to be the plus, correct? So I'd have to have 2 plus square root of 4 minus y squared minus, and then I have to cut out this little area right here. So I need that distance. That's 2 minus square root of 4 minus y all squared dy. And y goes from 0. Oh, where's that vertex? I think it's at 2. Y would go from 0 to 2. So, can we do it? Yes. Was it easy? No. And think of the mess you would have to go through now just to evaluate this problem. You'd have to FOIL this out. You'd have to FOIL that out. You'd have to combine your like terms. You're going to have square roots in your answers. You're going to have to use U substitution. Real pain in the neck to finish that problem off. There's got to be a better way. That's exactly right. There is a better way. And it has to do with shells. That's right. So we're going to use the method of shells to answer this same question. So we're going to have the same equation. And we're still going to spin it around that axis. Now, like I said a minute ago, when you're using discs and washers, when you have your line of revolution, your little strip has to be perpendicular. Always. For discs and washers, your line of revolution and your strip go perpendicular. When you use the shells method, your line of revolution and your little strip are always going to be parallel. So, to use the shells method, I get to build a strip that way. And immediately, that's a lot nicer. Why is that immediately a lot nicer? It's going to be in terms of dx, and my equation is already set up to use dx, isn't it? I don't have to get x all by itself. All right, now you got to think here. Think of having a teeny tiny little rectangle and taking that teeny tiny little rectangle and spinning it around the axis. What would you get? You would get a cylinder. Something that looks like this. So this is your, of course my little strip isn't the right length, but if your little strip is that length and you spin it around, you would get a cylinder. Like so. Now we need to find the volume of the cylinder. And when I say volume, I don't mean how much stuff could I put inside the cylinder. By volume I mean how much metal did it take to build this cylinder. What's the volume of this metal here? Nope, I don't want surface area, I want volume.
Wouldn't it be the circumference times how wide it would be? Like you take the circumference of that circle and then you basically multiply that by how big the circle would be and how tall it would be.
How come?
It would be the same thing.
Because you're just taking a circle and adding a bunch on top of each other.
I like Grace's answer better. Grace's answer is, and I wish I could do this with this, what if I could cut this right here, right where the weld is, and roll it out? What would I have? Well, I'd have a rectangle, but it would have a tiny little bit of thickness, wouldn't it? So I'd have a tiny, teeny little box. How do you find volume of a teeny, tiny little box? Length times width times height. Okay, so if I cut this and roll it out, how long is it going to be? It will be the circumference. So if I cut this and roll it out, the length would be the circumference. How tall would it be? It would be the height of this little strip that I started with, wouldn't it be? And what would the if I roll it out, how thick would it be? However thick the rectangle is. How thick is the rectangle? We have a symbol for how thick the rectangle is. Delta x or dx. All right, so volume is going to be, again, think of taking this strip, spinning it around, you get this can. I need to find the circumference. To find the circumference, it's 2 pi times the radius, correct? What's the radius of my can?
However far away that line is.
The radius is the distance from right there to right there. So how far is that distance? X, because this little strip can be put anywhere in there, right? So the volume is going to be 2 pi times x, because x is the radius, it's the distance from the origin to wherever I built my strip, times, so that's the circumference, and then we might have to multiply by how tall the can is. How tall is the can? The can is that tall. That's f of x. Times the thickness of the can. How thick is the can? Dx. And then I put an integral sign right in front of it to say, build an infinite number of rectangles and add them all up. So there's the formula for method of shells. So for this problem, our volume is going to be 2 pi times the integral of x times minus x squared plus 4x dx. And what are our bounds of integration? What's our interval? 0 to 4.
Explain why that's a cylinder, because isn't there a gap between the y-axis that you'd be fitting into that?
Yeah, that's why you have a hole in the middle.
All right. Oh, right. Okay. How will we put it together there?
Yeah, the hole in the middle is the gap between the axis and your line of revolution. Yep, and that's why we're only concerned about the metal itself, not how much stuff goes inside.
Because when you pull the cylinder out, it's just a disc for some reason.
Right.
They're called shells because
This shape is called a cylindrical shell. That's why it's called a shell. Shell's method. If you had to work that one all the way out to the end, would that one be easier?
Oh, yeah.
Oh yeah, a whole heck of a lot easier. Much easier. All right, so let's look at that one we had yesterday. Yesterday we had something that looked like this. Oh boy. Well, it's supposed to be more symmetric than that. That was y equals sine x from 0 to pi. Again, and we talked about if we wanted to spin this around this axis, around the y-axis, using the method of washers, we would have to build our little strip that way, horizontally. And that would be very ugly because we would then have to use the sine inverse function. And we don't have any rules at all about integrating sine inverse. We have rules about integrating sine, but not sine inverse. Big problem. But if I build my little strip this way, I'm in good shape. So my integral, my volume, would be 2 pi times the integral, my radius. What's the radius? The radius is the distance from where you're spinning to where you are. That distance is x. Times the height of the rectangle. How tall is my rectangle? Sine x. Times the thickness, which is dx. And our integral would go from 0 to pi.
So pretty much you just put like sine x in for f x
No,
No.
because we'll make them harder.
Okay.
What happens if we spin around a different line? What happens if we have multiple functions? What happens if we do both at the same time? It's a little harder. We'll see. Now, we still would have a problem with this one. The problem is we have multiplication right there. Do we have a product rule for integrals? No. Could we use U substitution? Maybe. What would U be? U is never x. U could be sine x, but I don't think that would help because when you take the derivative of sine, you get cosine. Do I have a cosine in there anywhere to balance with? No. Unfortunately, U substitution would not work on that problem either. There is a way to evaluate this integral. You will learn it in Calc 2 next semester with Mr. Evans. Something called integration by parts. It's the product rule for integrals. There is one that's called integration by parts, but it doesn't look like the product rule that you're used to.
Yeah, because you had to derive it.
You have to derive it. That's correct. All right. So now let's make it slightly harder. What do you want to do first? Do you want to spin around a different line, or do you want to have two functions? Two functions, all right. How about we have y equals x squared and y equals x. And we're going to stay in the first quadrant here because y equals x squared looks like that. Y equals x looks like that. And let's, for now, still spin around the y-axis.
Get you a weird bowl.
It would be a weird bowl because inside of the bowl would look like a cone because it's straight here. So it would look like an ice cream cone on the inside, and the outside would be curved. Yeah, it'd be a weird looking bowl, I agree. But it would be.
You can then stick a triangle inside that bowl and confuse a bunch of people.
Right, so maybe it would be really good for like tortilla chips. You could put triangles inside. I don't know. All right, anyway, if we are using the method of shells, which way do I build my little strip? Up and down or left and right? Up and down. For the method of shells, you always go parallel to your line of revolution. So our volume would be 2 pi times the integral. My radius is my distance from my line of revolution to where I'm spinning. So that would be x. How tall is that little cylinder? X minus x squared. Excellent. When you have more than one function, you have to go top minus bottom. X minus x squared dx. And x would go from 0 to 1 because those two graphs cross at the point 1, 1. Yes?
So the derivative volume of this and washers, you're squaring x minus x squared, but for this you're not.
Correct. You do not square them for this one. Why did we square them when we did discs and washers? Because we were using the formula pi r squared. For this one, we're using the formula for circumference, which is 2 pi r. So that's why there's no squaring in this one. Okay? Now, just for fun, because I think it's fun. It's debatable. That's true. It's not debatable that I think it's fun. I think it is. All right. Let's say we wanted to spin around the x-axis. And I still want to use shells. We could use discs very easily, couldn't we? Washers, actually. But very good. If I want to spin around the x-axis and I want to use shells, then I absolutely have to build my strip that way, which would immediately tell me I need to use dy. So this one over here, label these. This was spinning around y-axis, and this one will be spinning around x-axis. Volume will be 2 pi times the integral. All right, so now I'm going this way. So now my radius is my distance from my line of revolution to where I built my little strip. So now our distance is y. And then I need to take the length of this little strip. So I need to go right minus left. So what's the equation on the right? Square root of y. Excellent. Square root of y minus y dy. And I would still go from 0 to 1 because they cross at the point 1, 1. Questions on that?
It would be easier to use the distant washer method on the X.
For that problem, I think I would agree with you. For that problem, I think the discs washers method would probably be easier if I'm spinning around the x-axis.
So is this more useful when you're spinning around the y-axis?
Depends on the equations that you're given.
We have the choice on it.
Probably not.
Probably not.
That's not true.
Can you just tell us the bottom number?
That's not true. Y squared minus x squared. Thank you.
Well, maybe I only wanted the top half.
Well, you didn't specify.
Okay, we'll do the whole thing. You want to do the whole thing? Okay, I want to take that shape, and I wish to spin it around the x-axis.
1/2.
All right, so we only really have to do the top half,
Or do the whole thing all by 1/2.
or do the whole thing and multiply by 1/2. How come we only have to do the top half?
So it spins around, it's gonna.
Because when it spins around, the top half is going to become the bottom half. So I really only needed the top half, which is why I only wanted the top half. But you guys were fussy, so I did it both.
Well, we did it on the quiz.
On the quiz, I was asking for area, though. That's different. All right, so
Well, our issue was that you wrote the equation y squared equals x and then only drew one part of it.
well, I was going to write y greater than or equal to 0, but you guys are too quick. All right, so anyway, we only have to do the top half, right? Because when we spin it around, the top half is going to become the bottom half. So we only need to do the top half. All right, so this time, like I say, I want to spin around the line, the x-axis. My personal opinion is I would prefer to build my strip that way. Why would I prefer to build my strip that way?
You went from one function to
Because it always goes from the parabola on the right to the parabola on the left. How many integrals am I going to need? Only one. If, on the other hand, I chose to build my strips this way, how many integrals would I need? 2, because sometimes that parabola would be on top, sometimes that parabola would be on top. So sometimes one method is slightly easier than the other one. In this case, I don't think there's a huge difference, but because of the way those equations were written, and because of the way the graphs work out, I would prefer to build my strip that way, which tells me I would prefer to use the method of shells. How do I know if I'm building my strip that way, I'm using the method of shells? Because my strip is parallel to my line of revolution. Absolutely. So my answer would be volume is 2 pi times the integral. What's my radius? My radius is the distance from there to there. That's y. Times the right function. Okay, but I need to write it as 8 minus y squared. Everything needs to be in terms of y's. Minus my left function, y squared, dy. And y goes from 0 to, because that's the point 42 right there. Y goes from 0 to 2. Now, let's say I gave you that exact same picture, and I told you, now I want to spin it around the y-axis. Would you use the method of discs or the method of shells? Well, discs, washers. Washers. Discs and washers go together. Shells or discs, washers? I would use discs and washers. How come? Because I'm only going to need, if I do it, if I'm spinning around this line, my strip is perpendicular, that tells me that I could use discs and washers. If I want to use shells, I would have to build my strips this way. I would need one integral over here, and I would need a second integral over there. So which way is easier? There's no right answer on that. The truth is, which way is easier? Depends on the graph. Depends on the picture. Depends on what line you want to spin around. For this shape, sometimes discs and washers is easier. Sometimes shells is easier. Depends on what you're spinning around. And that's going to be true for most problems. For most problems, one way will be slightly easier than the other. Sometimes one way can be done and the other way is impossible, like the one we saw with sine x. I don't think that one's possible to do it using sine inverse. So we do it the other way. Questions on that? All right, the last thing we need to talk about is, what if you're not spinning around an axis? Yeah, what if you're going to spin around a different line? So let's go back to, we'll go back to this shape again, y equals x squared and y equals x. And now let's say I ask you to spin around a vertical line, but not the axis. Anybody got a vertical line they like a lot? X equals 4? All right, x equals 4 would be way over here somewhere. And we're going to spin around that line. So far over you couldn't see it. There it is.
And it's way over there.
It's way over there. You couldn't, off the edge of the earth. The earth being my piece of paper. All right, so we draw our little strip. Has to go that way if I'm using shells. Why does it have to go that way? Got to be parallel, correct? All right, so volume is going to be 2 pi times the integral. What's my radius? Not x this time. This is where it changes.
X plus 3.
Not x plus 3.
4 minus x.
4 minus x.
Yes,
Why?
because that's where the line is.
All right, so the radius, the thing you're going to put, is the distance from your line of revolution to where you built your little strip. So my radius is that distance right there. Why is that distance 4 minus x?
Because x is equal to this is y.
Because this distance right here is x, correct? And from the axis all the way to my line of revolution is a distance of 4. So that distance that I need is 4 minus x. So it's kind of the right minus left trick again. So when you spin around a line that's not the axis, your radius will not just be the letter x. It will be something else. In this case, 4 minus x. And then we still have top minus bottom, so that's still going to be x minus x squared dx. And x goes from 0 to 1. Because my region goes from 0 to 1. Lovely problem. Still not terribly difficult, though. You FOIL it out, find your antiderivative, plug your numbers in. I think that problem would be easier than doing this and doing shells. Not doing shells, doing washers. Why would it be easier? Well, you're not going to need more than one integral. You're only going to need one. But you're going to have square roots involved, aren't you? Because you're going to have to take the square root to write it in terms of y. You're going to have square roots involved. I think it would be slightly harder to do it the other way. I think this is the right way to do that problem.